Addressing the dilemma involves several key strategies. Firstly, acknowledge the skills and experience of the electricians, emphasizing the potential consequences of an arc flash and the necessity to mitigate these risks. Secondly, identify specific exceptions where zero-level lockout might be appropriate, considering situations with a low risk of arc flash. Thirdly, establish clear guidelines that outline the specific requirements for lockout/tagout procedures and the appropriate use of arc flash suits for various tasks. Fourthly, implement regular safety meetings to discuss the importance of NFPA 70E compliance, providing thorough training on arc flash hazards and effective mitigation strategies. Fifthly, seek input from the electricians, involving them in the development of safety guidelines and seeking their valuable feedback on practical, real-world solutions. When encouraging suit use without compromising efficiency, consider these steps. Firstly, provide convenient access by ensuring that arc flash suits are readily available in easily accessible locations near the primary work areas. Secondly, minimize suit assembly time by exploring options to simplify the suit assembly process. This might include the use of pre-assembled components or the provision of clear, concise instructions. Thirdly, consider partial suits by introducing the use of partial suits or arc flash jackets that provide adequate protection for specific tasks without the encumbrance of a full suit. Fourthly, implement a gradual implementation of arc flash suits over time to allow the electricians to adjust and become more comfortable with their use. Fifthly, reward compliance by providing incentives or recognition to those electricians who consistently adhere to safety protocols. Additional considerations include the following. Firstly, assess the work environment by conducting a thorough risk assessment to accurately identify specific areas or tasks that require additional safety measures. Secondly, use technology by exploring the use of remote monitoring or wireless communication devices to reduce the need for physical panel entry. Thirdly, seek external support by considering consulting with an electrical safety professional or an arc flash analysis expert for more comprehensive guidance. Finally, evaluate alternatives. If implementing zero-level lockout is not feasible, explore alternative measures such as the use of appropriate insulation, grounding techniques, or voltage reduction methods. Remember, the primary goal is to enhance safety without hindering productivity. By carefully considering these recommendations and working collaboratively with the electricians, a safe and efficient work environment can be created that fully complies with NFPA 70E requirements. An arc flash is a dangerous electrical explosion that can occur when there is a fault in an electrical system. The temperatures generated by an arc flash can reach upwards of 35,000 degrees Fahrenheit, which is 4 times hotter than the surface of the sun. These extreme temperatures can cause severe burns, blindness, hearing loss, and even death. The pressure wave from an arc flash can also cause significant injuries such as broken bones, internal damage, and traumatic brain injuries. Molten metal and debris are often ejected during an arc flash, posing additional hazards to anyone in the vicinity. The severity of an arc flash depends on several factors, including the voltage and current available, the distance from the arc, and the protective equipment worn. Understanding the potential dangers of arc flash is crucial for implementing effective safety measures. NFPA 70E, the standard for electrical safety in the workplace, provides guidelines for protecting employees from electrical hazards, including arc flash. Compliance with NFPA 70E is essential for ensuring a safe working environment for electricians and other personnel who work with only electrical equipment. Lockout/tagout procedures are a critical component of electrical safety. These procedures are designed to prevent the accidental energization of equipment while it is being worked on. Lockout involves physically disconnecting and securing the energy source, while tagout involves placing a warning tag on the energy isolation device. Proper lockout/tagout procedures ensure that equipment remains energized during maintenance and repair work, reducing the risk of electrical shock and arc flash. Arc flash suits are a type of personal protective equipment (PPE) designed to protect workers from the thermal effects of an arc flash. These suits are made from flame-resistant materials that can withstand high temperatures and prevent burns. Arc flash suits are rated according to their arc thermal performance value (APF), which indicates the amount of energy the suit can withstand before causing a second-degree burn. Selecting the appropriate arc flash suit for a given task requires careful consideration of the potential arc flash hazard. Conducting an arc flash risk assessment is essential for determining the appropriate level of PPE. This assessment involves evaluating the potential arc flash energy at various locations within an electrical system. The results of the risk assessment will determine the required ATF rating of the arc flash suit. It is important to use calibrated equipment and follow established procedures when conducting an arc flash risk assessment. The assessment should be updated regularly to reflect any changes in the electrical system. Training is a vital component of any electrical safety program. Electricians and other personnel who work with or near electrical equipment should receive comprehensive training on arc flash hazards, lockout/tagout procedures, and the proper use of PPE. Training should be hands-on and interactive, allowing workers to practice the skills they need to stay safe. Regular refresher training is also important to reinforce key concepts and ensure that workers stay up to date on the latest safety practices. In addition to arc flash suits, other types of PPE may be necessary to protect workers from electrical hazards. These include safety glasses, face shields, insulated gloves, and hearing protection. The specific PPE required will depend on the task being performed and the potential hazards involved. It is important to inspect PPE regularly for damage and to replace it when necessary. Establishing a strong safety culture is essential for preventing electrical accidents. This involves creating a workplace where safety is valued and prioritized. Management should demonstrate a commitment to safety by providing adequate resources and support for safety programs. Workers should be encouraged to report hazards and to participate in safety meetings. A strong safety culture promotes a proactive approach to safety, where hazards are identified and addressed before they can cause accidents. Technology can play a significant role in improving electrical safety. Remote monitoring and wireless communication devices can reduce the need for physical panel entry, minimizing the risk of arc flash. Infrared cameras can be used to detect hotspots in electrical equipment, allowing for proactive maintenance and preventing potential failures. Arc flash detection systems can quickly de-energize equipment in the event of an arc flash, reducing the severity of the incident. These technologies can enhance safety and improve the efficiency of electrical work. Consulting with an electrical safety professional or an arc flash analysis expert can provide valuable guidance in developing and implementing an effective electrical safety program. These experts can help to identify potential hazards, conduct risk assessments, and develop customized safety procedures. They can also provide training and support to ensure that workers are properly protected. Engaging with experts can enhance the credibility of the safety program and demonstrate a commitment to safety. It is important to regularly review and update electrical safety programs to ensure that they remain effective. This involves monitoring incident data, evaluating the effectiveness of safety procedures, and incorporating new technologies and best practices. The review process should involve input from workers, management, and safety professionals. Continuous improvement is essential for maintaining a safe working environment and preventing electrical accidents. Compliance with NFPA 70E is not just a matter of following regulations, it is a matter of protecting lives. By implementing effective safety measures, providing comprehensive training, and fostering a strong safety culture, organizations can significantly reduce the risk of electrical accidents and create a safer working environment for their employees. The information provided here is intended as a general guide and should not be considered a substitute for professional advice. Always consult with qualified professionals when implementing electrical safety programs. Addressing concerns about zero-level lockout requires a multifaceted approach that considers both safety and efficiency. Firstly, a comprehensive review of the existing lockout/tagout procedures is essential. This review should involve all stakeholders, including electricians, supervisors, and safety personnel, to ensure that the procedures are practical and effective. Secondly, a detailed risk assessment should be conducted to identify specific tasks and situations where zero-level lockout is appropriate and where alternative measures may be necessary. This assessment should consider the potential arc flash hazard, the complexity of the task, and the skill level of the electricians involved. Thirdly, clear and concise guidelines should be developed to outline the specific requirements for lockout/tagout and the use of arc flash suits for different situations. These guidelines should be readily available and easily understood by all employees. Fourthly, comprehensive training should be provided to electricians on the proper use of lockout/tagout procedures and arc flash suits. This training should include hands-on practice and should be reinforced regularly. Fifthly, a system should be implemented for monitoring and enforcing compliance with the lockout/tagout procedures and the use of arc flash suits. This system should include regular audits and inspections. Sixthly, incentives should be provided to encourage electricians to follow safety protocols. These incentives could include recognition awards or bonuses. Seventhly, the company should invest in providing convenient access to arc flash suits. This could involve placing suits in readily accessible locations near work areas or providing mobile arc flash suit stations. Eighthly, the company should explore options to simplify the suit assembly process. This could involve using pre-assembled components or providing clear and concise instructions. Ninthly, the company should consider the use of partial suits or arc flash jackets for specific tasks that do not require the full protection of a full suit. Tenthly, the company should implement a gradual implementation of arc flash suits to allow electricians to adjust and become comfortable with their use. 11thly, the company should assess the work environment to identify specific areas or tasks that require additional safety measures. This could involve installing additional barriers or providing additional training. 12thly, the company should explore the use of technology to reduce the need for physical panel entry. This could involve using remote monitoring or wireless communication devices. 13thly, the company should seek external support from an electrical safety professional or an arc flash analysis expert for guidance. 14thly, the company should evaluate alternatives to zero-level lockout, such as appropriate insulation, grounding, or voltage reduction. 15thly, the company should foster a culture of safety where employees are encouraged to report hazards and to participate in safety meetings. 16thly, the company should regularly review and update its electrical safety program to ensure that it remains effective. By carefully considering these recommendations and working collaboratively with the electricians, the company can create a safe and efficient work environment that complies with NFPA 70E requirements. It is important to remember that safety is a shared responsibility and that everyone has a role to play in preventing electrical accidents. The most important element is to create a safe work environment that is compliant with safety practices and to encourage wearing PPE, personal protective equipment. Always be sure to have a professional that understands safety standards perform any type of maintenance work on electrical equipment. Do not proceed if you are uncertain. Contact an outside consultant to have them inspect the equipment and ensure that all safety hazards are properly mitigated.